Now we will see method of differentiations, some basic miscellaneous problems. First problem, differentiate. Tan of secant x. Take y equal to tan of secant x, okay, dy by dx equal to, now differentiate with respect to x. We use chain rule here. We know differentiation of tan x is secant square x, okay, d by dx of tan x equal to secant square x, okay. Again d by dx of x is 1. So secant square x into 1 is secant square x. Similarly, now we differentiate tan of secant x. Differentiation of tan of secant x is secant square secant x. Again differentiating the secant x. That is called chain rule, okay. D by dx of secant x. So secant square secant x. We know d by dx of secant x is secant x tan x, okay. So into secant x tan x. That's all. Okay. So instead of x, we get secant x in bracket. So again differentiating secant x. So we get secant x tan x. Okay. Next, second problem. Differentiate secant of sine root x. Okay. Now take it as y. Y equal to secant of sine root x. So we know d by dx of secant x is secant x tan x. So apply the formula here. Differentiation of secant of sine root x is first differentiate secant and then differentiating sine root x. That is chain rule, okay. So dy by dx equal to secant of sine root x. Don't disturb sine root x inside the bracket, okay. Again write tan d by dx of secant x tan x. Similarly, secant of sine root x tan of sine root x. Now differentiate sine root x, okay, by using chain rule. That is a chain rule. Again differentiating sine root x, okay. We know d by dx of sine x is cos x. So d by dx of sine root x is cos root x. Again differentiating root x, okay. So write secant of sine root x tan sine root x. Differentiating sine root x is cos root x into d by dx of root x, okay. We know d by dx of root x is 1 by 2 root x. So secant sine root x tan sine root x cos root x into d by dx of root x is 1 by 2 times root x, okay. That's all. Next problem, third one. Differentiate cot of tan root x. So you know basically differentiation of cot x is minus cosecant square x. D by dx of cot x is minus cosecant square x. Okay. Instead of x, we get tan root x in the bracket. First differentiate cot and then differentiating tan root x. Okay. Take y is equal to cot of tan root x. Now differentiating both sides with respect to x. dy by dx. A differentiation of cot is minus cosecant square. Okay. So minus cosecant square. Don't disturb tan root x inside the bracket. Okay. We differentiating tan root x separately. Not in the bracket itself. Okay. Write tan root x in the bracket and then differentiate tan root x. That is very important steps. Okay. So d by dx of tan root x. D by dx of tan root x is secant square root x. Again differentiating root x. Okay, that is chain rule. So minus cosecant square tan root x secant square root x d by dx of root x. Okay. We know d by dx of root x is 1 by 2 root x. That's all problem. Minus cosecant square tan root x secant square root x into 1 by 2 root x. That's all. Next. Fourth problem. Differentiate cos x square plus cos square x cos square x square cos square x square. First take it as y. So y is equal to cos x square cos square x cos square x square. Okay. Cos square x means cos x into cos x. Cos square x square means cos x square into cos x square. Okay. Basically the differentiation of cos x is minus sin x. So differentiation of cos x square is minus sin x square. Okay, so we know d by dx of cos x is minus sin x into d by dx of x. D by dx of x is 1. So sin x into 1. So we get minus sin x. Again differentiating x, we get 1. So 1 into sin x is sin x. That is the method. Okay. Similarly, instead of x, we get x square. So we after differentiating cos, we differentiate x square separately. Okay. Dy by dx is equal to differentiation of cos x square is minus sin x square into d by dx of x square. We differentiate x square separately. Okay. plus differentiate cos square x. We apply power rule. Okay, we apply power rule. F of x power n. F of x power n is n times f of x power n minus 1 d by dx f of x. Okay, so y is equal to any functions in the power, we follow this formula. Okay, dy by dx is equal to n times f of x power n minus 1 into d by dx f of x. Here in cos square x, what is f of x? F of x is cos x. N is 2. We apply the formula here. 2 times cos power 2 minus 1 is, that is 1. Again differentiating cos x, it become minus sin x. Okay, so differentiating cos square x, 2 cos 2 power in power 2 minus 1, we get 1, we write it as cos x. Okay, don't stop. Okay, continue this again, differentiating this cos x, that is f of x. Here f of x is cos x, so d by dx of cos x plus over next one cos square x square. Again differentiating cos square x square, we apply power, same power rule. Okay, same power rule. Differentiating cos square x square, 2 cos again power 1 x square. Okay, instead of in previous term we get x, in this term we get x square. So write cos x square d by dx of the base f of x. What is the base? Cos x square. Okay, in cos square x square, what is f of x? Cos x square. What is n? N is equal to. In cos square x, what is f of x? Cos x. N is equal to 2. Okay, so we get any function, in power, we apply this power rule only. Okay, n times f of x power n minus 1 d by dx f of x. Okay, so dy by dx is equal to minus sin x square. In every term we get the differentiations. Again differentiation of x square is 2x, 2 cos x, d by dx of cos x is minus sin x plus 2 cos x square. Differentiating cos x square, we get minus sin x square. Again differentiating x square, don't forget to differentiate x square again. Okay, d by dx of cos x square is minus sin x square, that is chain rule we apply into d by dx of x square. So simplify, so minus 2x sin x square plus into minus 2 sin x cos x, again plus into minus 2 cos x square sin x square, d by dx of x square is 2x, then multiply with the last term. Okay, so we get minus 2x sin x square minus 2 sin x cos x minus 4x, 2x into 2, 4x cos x square sin x square. Okay, next fifth problem, differentiate square root of tan root x. Okay, so under root tan root of x. To differentiate this problem, we apply square root rule. Okay, we apply square root rule. So y is equal to square root of f of x. So dy by dx is equal to 1 divided by 2 times root f of x into d by dx of f of x. Okay, every time we differentiating f of x, don't forget to differentiate this function separately. Okay, that is very very important. Here first we take y, the function as y, so root of tan root x. We apply this rule, dy by dx is equal to 1 by 2 times, write the given function as it is, comparing with the square root rule. What is f of x here? F of x is tan root x. Okay, so 2 times tan root x, differentiating f of x. What is f of x? Tan root x. Here this is called f of x. Under root function is called f of x. Okay, so d by dx of tan root x. So we know d by dx of tan x is secant square x. We apply the same formula, secant square root x, again differentiating root x. If it is tan x, we get d by dx of x is 1, but here we get the term as root x. Okay, so 1 by 2 times tan root x into secant square root x, again differentiating root x, that is 1 by 2 root x. I am writing directly. Okay, I am skipping the one step. 2 2's are 4, so we get 4 into tan root x, okay, into secant square root x into root x. Okay, I am writing here. That's all. Next one, sixth problem. Differentiate square root of under root of secant x minus 1 divided by secant x plus 1 and also find f dash of pi by 3. So f dash of pi by 3 means after differentiations we substitute x is equal to pi by 3 and find out its derivative values. Okay, take it as f of x or y, f of x, y, both are same. So square root of secant x minus 1 divided by secant x plus 1. Now don't differentiate as it is. First we change into cos x, because we know secant x is 1 by cos x. Okay, we know secant x is 1 by cos x, because after change of cos x, we use this formula 1 minus cos 2x or 1 minus cos x 2 sin square x by 2. So remember all trigonometry formulas. Okay, before doing differentiation and iterations, you must thorough with all trigonometrical formulas. Okay. Again 1 plus cos x, 2 cos square x by 2. If it is 1 minus cos 2x, we write 2 sin square x. Okay. 1 minus cos 2x, 2 sin square x. 1 plus cos 2x, 2 cos square x. Okay, this is the formulas. Okay, first I am changing into cos. Okay, we know don't differentiate directly. First we change secant into cos. So 1 by cos x. So in this method we reduce the steps. Okay, we reduce the steps. By 1 by cos x plus 1. So f of x equal to, take LCM. So 1 minus cos x by cos x so in the denominator also take LCM 1 plus cos x by cos x. So f of x equal to, okay, this cos x cancel. So 1 minus cos x by 1 plus cos x. Now use the formula, this formula, 1 minus cos x is 2 sin square x by 2, 1 plus cos x is 2 cos square x by 2. So f of x equal to square root of, under root of 2 sin square x by 2 divided by 2 cos square x by 2. These 2 to cancel. Sin square by cos. We know tan is equal to sin by cos. So square root of tan square x by 2. F of x. So f of x equal to square root of tan square x by 2 is tan x by 2. Okay. Now differentiate. We know differentiation of tan x is secant square x. Apply same differentiation of tan x by 2 secant square x by 2. And then don't forget to differentiate x by 2 separately. Okay, into d by dx of x by 2. That is a chain rule. So d by dx of x by 2 is 1 by 2. Okay. D by dx of x is 1, by 2 is a constant. We know d by dx of kx is k times into 1, d by dx of x, k. Similarly 1 by 2. What is k here? K is 1 by 2. Okay. So d by dx of kx. K is a constant. Okay. Don't differentiate constant. If it is in separate, d by dx of constant is 0. But k is in product with a variable. Okay, so we write k separately and then differentiating x only. So d by dx of x is 1, that is k. Okay, so d by dx of x by 2 is 1 by 2. So write 1 by 2 secant square x by 2. That's all. Okay, and then question is find f dash of pi by 3. Okay, to find this is f dash of x. To find f dash of pi by 3, we substitute x is equal to pi by 3. So put x is equal to pi by 3. So f dash of pi by 3 is equal to, so 1 by 2 secant square pi by 3 by 2, that is pi by 6. Secant square pi by 6, okay. Secant pi by 6 is 2 by root 3. That is a reciprocal of cos. We know cos pi by 6 is root 3 by 2, okay. Secant is a reciprocal of cos, 2 by root 3 the whole square. So 1 by 2 times 4 by root 3 square is 3, okay. 4 by 2 is 2, we get the answer as 2 by 3, that is equal to f dash of pi by 3. Okay. Next time. Seventh problem. Differentiate e power e power x, okay. So first take it as y is equal to e power x, okay. To differentiate we apply exponential rule, okay. What is the exponential rule here? Y is equal to e power f of x. Dy by dx is equal to, write the exponential function as it is, into d by dx f of x, into d by dx of f of x. This is the exponential rule, okay. This is the exponential rule to differentiate. Comparing with this exponential rule, what is f of x? F of x is this e power x, okay. This is taken as f of x. This is taken as f of x, okay. So differentiation of e power f of x is e power f of x, right, as it is, okay. So dy by dx is equal to e power x into d by dx of f of x. What is f of x here? E power x, okay. Again differentiate, again we apply the exponential rule. In this e power x, what is f of x? This is f of x, okay. So e power x, right, as it is. We follow again exponential rule. E power f of x is e power f of x. I am writing e power f of x, d by dx f of x. In this e power x, what is f of x? E power x. So d by dx of e power x, okay. What is d by dx of e power x? E power x, okay. So we get the answer as e power x, e power x, e power x, okay. This is the answer for the differentiations.